So to help you all review the rational functions information that we talked about before break, I've created a little video that goes along with the flip chart page that I provided you in class. So these first three examples talk about simplifying rational expressions, reducing them, multiplying them, and dividing them. And so what I'm going to do to save time on the video is I'm going to pause the video. I'm going to go ahead and factor each of these expressions so that we know what to do after the fact. So if you need to practice some factoring, this is a time to pause the video as I factor each of these expressions. All right, so I factored each of these expressions, making sure to check for a GCF first. Now, it is after you factor that you look for those bad values. So, for instance, in this first example here, I'll look at the denominator and only the denominator and the two bad values that are there. X cannot be -3 and X cannot be -5 because those make the denominator equal to 0. But I factored the numerator and the denominator, and when I do so, then I'm able to cancel out those x plus 3's. So my remaining expression is x minus 2 over x plus 5. In the second example, down here, the multiplication problem, again, I factored everything. And when I did, anything that was on top remained on top, or in the numerator of the large fraction, and anything that I factored in the bottom remained, or went to the bottom of the large fraction. So as you can see, the x minus 8 is still here as my first numerator. Here's my first denominator as I factored. And then my second numerator here is the only place where I had a GCF of 4x, so I took out the 4x, which left me with the x plus 10 inside. And in that second denominator right there, it did not factor, so I didn't have to worry about it very much. Now, again, it's at this point where I can list off the bad values. And again, I'm only looking at the denominator. When I do so, I see it from the first parenthesis, x cannot be 8. Then I see that x cannot be -6. And x cannot be -10. But then I start marking out my common factors for the pieces that match. And what I'm left with is a 4x in the numerator and an x plus 6 in the denominator. Then with the third example over here to the right, that's a division problem. And the only difference between division and multiplication is that you have to remember to keep, change, and flip. So with the first fraction here, I simply factored everything I could. I factored the numerator, I factored the denominator, and the results are where they match up with what you had to begin with. The division changed to multiplication, and then I flipped the second fraction and only the second fraction. And it did not have to be, it could not be factored. This x plus 10 right here couldn't be factored. But again, it is at this point that you list off the bad values. So as I look at my denominator, x cannot be +10, x cannot be -8. And then with division, you do have to do one more thing, and that you have to go back and go to your original denominator. The original denominator, I could not plug in a -10 either. So you also have to include that when you're listing off those bad values. But it's only with division that you have to do that. But then I go through and start reducing what I can. So these x plus 8's will cancel out, and I'll be left with the x minus 7 and the x plus 10 from the second fraction all over the x minus 10, and you don't need to include that one. So when you're asked to simplify and it's only involving reducing, multiplying, and dividing, essentially you're just factoring. Now when you add and subtract, you do have to have common denominators. In this first problem, I do already have common denominators. So when I add those two fractions, x plus 5 will remain as my common denominator, and then I'll just combine like terms. So I'll have 2x plus x, so that'll give me 3x. And then I'll have 3 plus negative 6, which will give me a negative 3. Now, if you want to try to reduce that, you can see what will factor. You can take out a 3 as a GCF in the numerator, but as you can see, even when I do that, I can't reduce anything anyway, so I can really just leave my answer as I had it. On the second example, I don't have common denominators. I've got two different denominators. So the easiest way to get a common denominator is just to put the two together. So to do that, I'm going to have the x minus 6 and the x minus 4. So for my new numerator, the 6x that was there to begin with is still there. But this time, it does get multiplied by the x minus 4 because the original denominator was missing this expression. The minus sign comes down. The 6 that was there originally is still there, but this time it gets multiplied by the x minus 6 that wasn't there at its denominator before. So once you have your new numerator set up, you're going to simplify. And in this case, we start that by distributing. So I will have 6x squared minus 24x. And then I'm going to distribute this negative 6 to both terms. So I'll have negative 6x plus 36. And then in the denominator, I'm going to leave it as it is because, again, it allows me to see what the bad values would be. In this case, they would be positive 6 and positive 4. Those would be my bad values. But multiplying really doesn't accomplish anything at this point. So the only thing I have left to do to finalize my expression is to combine like terms in the numerator. So that's going to be 6x squared minus 30x plus 36. So when you're solving rational equations, if you have a situation where you just have a fraction equal to a fraction, you will cross multiply and set what you have equal to each other. Since the first example is pretty straightforward, I'm just going to go on to the second example. So I'm going to cross multiply the numerator, which is the x minus 4, times the denominator, the x plus 3. Then I'm going to set that equal to what I get when I'm multiplying the other direction. So I'll have the 1 times the 3x minus 7. And from there, you need to simplify, combine like terms, solve your equation. So we'll start by distributing or FOILing on the left-hand side of that equation. So we'll have x squared plus 3x. Then we'll have the minus 4x. And we'll have the minus 12. And on the right-hand side, we'll have 3x minus 7. We need to distribute the 1. I'll combine like terms. And as I do that, I see that I am dealing with a quadratic equation because I've got this x squared term. So you need to get everything to the same side of the equation so that you can solve that quadratic equation by hopefully factoring or the quadratic formula. So we're going to move everything to the left-hand side because that's where our x squared term is located. So to do that, I'm going to subtract the 3x from the right-hand side to the left-hand side, and I'm going to add the 7 from the right-hand side to the left-hand side. So we'll have x squared minus 4x minus 5 equals, and everything on the right-hand side of the equation cancels out, so it equals 0. And then from here, you'll want to take this equation and solve, which means you're going to want to factor. And you should find that you have two solutions after you factor, those solutions being positive 5 and negative 1. And with these types of rational equations, once you get your two solutions, you do want to make a habit of going back to your original equation and making sure that they work, that you haven't found an extraneous solution along the way. So in situations where you're trying to solve rational equations, when you don't have a fraction equal to a fraction, you're going to have to try to clear the fractions, which means you're going to multiply the whole entire equation by whatever the common denominator would be. And in this case, the common denominator would be x plus 2, because in fact that's the only denominator. Now some people like to see that over 1 to help them see that that x plus 2 on top will reduce away any x plus 2 that's in the denominator. So when you multiply this first fraction by that stuff outside, the x plus 2 in the denominator cancels out the x plus 2 in the numerator, so you're just left with 9 over 1, or 9. When you multiply the second fraction by the expression that you have outside, the x plus 2 in the bottom and the x plus 2 in the top cancel out, so you have just the 3 over 1, or 3. Then you're going to add that 2. Now when you look at that third piece of your equation, it doesn't have a denominator, so nothing is going to cancel out. So you're still going to have that 2x, and you're going to have to multiply that 2x by the stuff that you've got outside. So I'm not going to completely finish solving this equation because I want to look more carefully at the next one, but you will get a quadratic, and you will need to get everything to one side, and you should get something that factors so that your answers are -3 and +1. On this last rational equation that you're going to need to solve, again, because you don't have just a fraction equal to a fraction, you're going to have to clear the fractions. In this case, you've got one denominator here, one denominator here. Now this third one actually factors into x plus 4 and x minus 4. So really that third denominator is just a combination of the first two. So you're going to multiply everything in the equation by the x plus 4 and the x minus 4. So when you do that, when you multiply that first fraction by this stuff that's outside, the x plus 4 in the denominator cancels out this x plus 4 on the outside. So you are going to be left with the x that you had to begin with in your numerator, and you're going to multiply that by the x minus 4 from the outside that didn't get reduced away. The minus sign comes down. When you look at the second fraction, the x minus 4 in the denominator will cancel out the x minus 4 that's outside. So you'll still be left with the 3 that you had to begin with and the x plus 4 that didn't get reduced away. Equal sign comes down. And then you consider that third fraction. Well, with the third fraction, both pieces in the denominator cancel out both pieces that are outside, so you simply have a -22 left. And from there, like the other ones, you need to start distributing. And then you see that you've got a quadratic. You're probably going to want to combine like terms. And then, because it's a quadratic, you're going to want to get everything to the same side of the equation, which in this case is going to mean taking that -22 to the other side by adding it. So you'll wind up with x squared minus 7x plus 10, and set that equal to 0. Then you will see that this factors, and you have two solutions to your original equation. Don't forget to plug back in and check.